Welcome to theme 2.3, where we will be discussing the basics of triple integrals and what we use them for. So in the previous themes, we had double integrals, where we had a height function and boundaries for x and y or r and theta in polar coordinates. When we had a paraboloid like this, and we wanted the volume inside. For triple integrals, we will take the height function and we will make it into a new integral. So where your z value was from 3 to minus x squared plus y squared, now we will introduce a new integral where that is taken into account, where it goes from 3 to minus x squared plus y squared, 1 dz dx dy, and this will give you volume. Triple integrals can also be used to give you a mass, where it will have a function inside, which will be a density function, and you will have 3 integrals. So triple integrals are more complex than the double integrals, where you can project a triple integral volume, or let's say you have a cube, then you can project it on your xy plane, your yz plane, or your xz plane. I will explain. So if we had a integral as per se, and it had a dz in the middle, which will correlate to this integral, then it was projected onto your xy plane. So this dA will be dx dy, or it can be dy dx. So it can be type 1 or type 2. What I mean with projecting onto the xy plane is the following. You will have your volume here, and it will project an area onto your xy plane. So either your x or your y plane will have an interval described by numbers. Since it can also be projected onto the yz plane, you will have an triple integral that will have a dx on the inside, and you'll have a dA which can also be described by type 1 or type 2. So this can either be dz dy or dy dz. And it will look something like this. So your volume will be projected onto your zy plane. So either your z and your y interval will be described by numbers. And then lastly, your xz plane, where the inside will have a dy. And this dA, as for the others, can be type 1 or type 2. And this will look like this, where this is z, y, and x. Okay, for an example. E is the region bounded by the coordinate planes, and the plane 2x plus y plus z is equal to 3. Give an iterated integral for the mass E if the density at any point is the same as the distance to the xz plane. So before we jump into this question, I just want to explain the distance to the xz plane will be y, and the distance to the xy plane will be z, and the distance to the yz plane will be x. So they will always give you a density function, and a lot of the times it will be in terms of something like the distance to a certain plane. So for this volume, we need to choose for ourselves on which plane we will be projecting it, because they didn't ask or give us a specific plane to project it on. But first, we draw what this volume would look like. So we know that it is bounded by the coordinate planes here, and that it is the plane of 2x plus y plus z is equal to 3. So to get these intercepts, so if you want the intercept of z, you let x and y equal to 0, and you want y, then you say x and z is equal to 0. And if you want the x, then you say z and y is equal to 0. So now that we have an idea of what it looks like, we choose the plane on which we will be projecting. If we choose the xy plane, then we let z equal to 0 in the plane equation. So in this case, I did choose xy plane to project on, so I let z is equal to 0. So then the plane equation will look like this, or it will look like this if rearranged. So we keep the same intercepts that we saw earlier in the three-dimensional drawing. And this is then our region projected onto the xy plane. Now, since we have our projection, we have to choose, is it going to be dx dy, or is it going to be dy dx? So in other words, is it going to be type 1 or type 2? So for type 1, we have x's interval described by numbers. So we can see that x goes from 0 to 3 over 2, and y goes from 0 to 3 minus 2x, which we got from manipulating this function. Now, for type 2, we will have x going from 0 to minus a half y plus 3 over 2, and y will go from 0 to 3. Now that we have our dx dy boundaries, we will move on to getting our z boundaries, since we didn't choose z to be part of the projection. So we have to look at our three-dimensional drawing to see what the boundaries of z will be. So in this case, we saw that the boundary of z was between 0 and the plane. And our density function was y. And this is going to be the two first integrals if you have type 1. So you will have x going from 0 to 3 over 2 and y going from 0 to minus 2x plus 3. But this doesn't change since it wasn't part of your projection and it's not part of type something. These last two dy's or dx's is the two that will have a type 1 or type 2. Now if you chose type 2, this is what your triple integral would have looked like. Once again, this integral wouldn't change, but these two change. Note that for the specific question, you could have chosen any plane to project on. Instead of choosing the xy plane, you could have chosen the xz plane or even the yz plane. I just chose by random the xy plane. So in other questions, they could ask you specifically for a certain projection. Let's say they ask for an order of integration of dy, dz, dx. So what would that mean? What it would mean is that you would have to project on the xz plane, and your x would have to be described in terms of numbers, and your z would have to be described by functions. And your y will not be projecting on. You will have to find your y by looking at your drawings. And if it were given like this, then you would have it projected onto the xy plane, and you would need to find the z boundaries by looking at your drawing. And the following, this would have been projected onto your yz plane, with your z interval being described by numbers and your y interval being described by functions. And your x interval, you would have had to look on your graph, and it would be also described by functions. So the first two closest to the middle will always be described, or mostly be described by functions, whereas the last one always needs to be described by numbers.